I bet you couldn't hear me because I wasn't on the stream, right?
No, I couldn't.
Oh, very sorry. You're. I was just introing you. You're up. Your face is up on the screen here at Worthy.
Oh, cool. Hello.
Yeah, I'm gonna remove myself from the stream, which means you can't hear me. Which is, I know it's weird for you because you're just staring at your computer, but you're talking to the room.
All right, sounds good. I can hear. Actually, no, I can't hear anything. Never mind. It's okay. I can hear you now, but I won't be able to hear you after he removes himself. So
yeah, I wonder if I just. Nah, I'm gonna. Do the one with the two sides. You just do your talk. You're ready to do it. You can do it.
Yeah. Let me share my screen and make
sure.
sure.
Yeah, share your screen first. Oh yeah, there you go. Yeah, I'd like to just maximize it, but I need to arrange the thing first.
That's yeah. Whatever you did, we were both on the left-hand side. I guess this works too. Okay. Well, no feedback at all. And I thought my jokes didn't kill before. They're definitely not going to work now. Okay, so just going to assume you guys can hear me. This is so weird. Okay, so this is about Hasura. Hasura is both an open source tool, and it's also a PaaS. You've heard of SaaS companies. It's PaaS, like Heroku Platform as a Service. So stop me if you ever heard these before. A front-end dev talking to a back-end dev. Hey, I need the user's name returned in the user query. The back-end dev responds, yeah, I'm gonna have to get that to you later next week, right? It's something that we all interact with on kind of a day-to-day basis, not necessarily, but hey, I need an extra field returned. Is there any way you can get this to me? Or another one, which is talking to a product manager. Hey, after the user signs up, and also every 5 minutes thereafter, can you send out an email telling the user how special they are and how if they don't use our product, they're not going to feel love and will exist in existential pain for eternity, right? So product wants this feature ad where an event happens and we want to do something based on that event, right? So this is kind of where Hasura comes in. So Hasura, basically think of that middle layer in between the database and the client-side application. It handles that logic flawlessly. All your Ruby on Rails, your Node.js logic, the business logic, it's just a super fast, easy way to create that logic, right? So you get, out of the box, you get an instant API from any Postgres database, and I'll demo that. These things called actions, which are custom queries that can be resolved by HTTP handlers, think like Cloud Functions or AWS Lambdas. Eventing, so on database insert, on column update, on row delete, do a particular thing. There's also cron jobs, and I'll kind of show those as well. And then it'll also handle auth for you. So column-based permissions, row-based permissions. It does this using JWTs. So you set particular roles for a user on their session token, and then Hasura can parse that out and provide auth. So, the Instant API is really kind of its main flagship feature. And like I said, you can think of it as this middle layer in between your application and the database, right? So it's exactly like, Rails or Node. And I'm going to show exactly how that works here. So this is a super small Hasura instance. This is running on their own cloud provided instance. So I set this up earlier. It's just one button. You can see there is a connected database, but it doesn't. It's not tracking any tables, right? There's no tables that are being tracked. So I'm going to open up Table Plus, which is kind of like, it's basically like can't remember. It's some programming jargon that they use to describe, but it's a client-side way to interact with a Postgres database. This is really any kind of database. So I'm just going to create a table. I can't remember if it has 2 T's or 1, but I'm just going to call it like attendees, right? So BendJS attendees. We can have an ID column, and then we can have, let's do just a name. Let's do text is mobile. Actually, let's just do yes. Home default empty. Okay. So now we have this what is it, attendees table with nothing in it, right? And you can see that right here, and it's completely empty. So on Azura, we have a connected database, and we can view it. And now we can see that there's now a table in here, right? And so we can choose to now track this table. So what Azura is going to do is it's going to inspect the Postgres database and then gather all the information from it, and then it's going to create an API that you can instantly query based off of all the fields that are in there. So you can query it, get stuff returned, and you see that there's nothing in there, right? What's awesome about this is, but now you can instantly interact with it from any client. So this is just an HTTP request tool. So I'm just hitting the Azure instance, making the request, and I'm not getting anything back, right? I'll just add a fake row here. Name, let's do Kyle. Now you can hit it. Get back 2 items, right? So
Command plus and zoom in a couple of
times.
times.
Yeah, for sure. Yeah. Can't do it on this one, but so you can see here there's this query that I'm passing over, automatically generated fields, so you can do things like by primary key, set all your primary keys, things like that. So now actions. So actions are the way that you're going to handle all of your business logic, right? So which one is it? Actions. So it's again that middle layer. So instead of just you're like asking for a particular field out of the Postgres database, say you want to do some computation on the thing before it gets resolved, right? So you can create a custom action. And because it's GraphQL, you have to define the types that are going to be passed in, and also the types that are going to be returned. So I'm just going to do, let's just do, I don't know, random. And then let's make a query. And then this is going to be the name. String pi, which is going to be a float, and then age, or what is it, int, right? So, and then let's do person. So now you define a handler, and this handler can be any URL that can accept an HTTP request and give you this JSON response. So I set up just a small node server on my local machine, and I'm going to have it handle this response. So the handler is just going to be ngrok is a tool. It's actually super handy if you're doing a lot of debugging. So this URL, which is a public-facing URL, will proxy to my local machine. BendJS. So my local machine is going to handle this request and give it a response. So I should be able to create it. And now from the API, I now have this random action that can be called return age, return the name, return response, and also I can pass it, let's say, slim, shady, something like that. I don't know. And it should be good. I can send it. And then you can see my local machine, all it does is just return the super simple JSON. And then if I want to get, what did I call it? Name. On the right-hand side, you can see Slim Shady makes it to my local machine. So that's pretty cool, right? Like you can, one, get an instant GraphQL endpoint from any database. Then you can do custom handlers as provided by a GraphQL interface. What else can you do? So eventing. So I think background jobs, doing a particular action based on an event, and again, having those handled by a handler such as a custom one like this. So we can kind of set that up just to show how easy that is. So event triggers. So you can do one-off scheduled events, which are things like like manually triggered events or crons. Crons are like run on a particular interval, like every day, every Sunday, things like that. Or you can do on row inserts. So let's do like on new user. So every time a new user gets inserted into the attendees table, we want to have a custom webhook that gets called to handle that particular event, right? So I'm just going to have it go to the same handler as I already set up. BendJS. And then on, so you can specify the on, the triggers that you want to trigger this particular URL. Then you can create the trigger. So now you can go, I'm just going to go back and test it. I'm going to create a mutation. A mutation is a modification to the database as opposed to a query where you're just asking for data. So mutation, and then insert attendees. I think it would be affected rows, and then it's just going to do the default values. I'm not going to worry about stuff, but you should see, I think it gets passed over in the body. I don't remember. Yep, so you can see this is the data that Azure sent over to my trigger. So it has what happened on the table that it's been being inserted on, the ID, the created at, and then the data that was modified. Right, it was the old data, as obviously there wasn't anything in there, which I think is pretty cool, right? Like this thing happens, then do this and handle it in a timely fashion. And then what else? So, and then there's auth, right? So like everyone probably here has an application that deals with auth on some level. Azure handles it in a really cool way. So all you have to do is pass over a JWT, and it'll parse that JWT based on a server-side variable, and then reference it against a particular column that you've specified. So for this application, let me see here. Will it show? Sorry, I'm gonna have to take steal a. Okay, well, I don't remember what the JWT is, but pretend that I had one here and you can parse it, and then I'll show you how it would look in the database. So on a particular user, so for instance, you only want to allow users to edit their own fields, right? Like not like I shouldn't be able to edit Chris or Kyle's, they shouldn't be able to edit mine. So you would want to allow them to make updates based on their particular user ID that's passed over in the JWT. And then you can allow them to edit particular fields that you want them to, and have presets like that, which I think is also very handy. And then, like I said, there's a self-hosted version, which is open source and free, which is awesome. So you get Git control, version control, and then migrations are another thing that I wanted to talk about. Like if you think about it, if your database changes, does your API also change? So really, this entire thing should be managed by configuration files, because you should be able to take a configuration file and then apply it to Hasura, and then all of a sudden you have a completely different API, right? So you run SQL through a particular config file, what you want to be tracked, the schema that applies to, and all that kind of stuff. So that can all be managed in Git. So your entire API is managed in Git. And then you can get a Docker image as well. I use it on Cloud Run, so it's kind of like serverless, and you just get some nice benefits. Then there on Hasura, the company's service, so if you want to host it on their cloud, you get 1 gigabyte of pass through a month, which is just how much data you're sending through. 60 requests per minute. You guys, I'm sure, know how to read. And then you on their standard, which is $100 a month, you get unlimited pass through. Some nice monitoring, which you can set up yourself on the self-hosted version, and then query count and query performance. I did want to show one really cool thing, which might kind of shed some light onto how powerful this is so for any query you can do, let's say I want to get all the attendees, you can analyze it, which will show you exactly the SQL that it translates into, and then also how much time is spent in CPU-wise trying to actually find those rows and how it plans to execute those, right? So how many rows it goes through, and how much it costs the system, which is pretty nice. And can't remember what that does, but yeah, it's fun. Cool. It's kind of all I have. Yeah.
Cool. Thanks, Kyle.
Yeah.
Listen to your applause. It's uproarious.
Yeah. Cool. Thanks for.
Yeah. So you said you ran it on Cloud Run. You did the free thing.
Yeah. So they have a Docker image. The unfortunate part, so it got really popular in open source, and then seems to be, at least lately, like anytime a project is popular in open source, they start a company around it. And so their older versions are in a Docker image on open source, and so you can use those. But a lot of the newer stuff, like caching, like monitoring, things like that, they want you to pay for. But if you have experience doing like AWS, GCP type things, you can set that all up yourself. So it's not like a huge deal. Yeah.
Sounds like they regret being open source.
Yeah, probably, to be honest.
So and it connected to a Postgres database where you were in Table Plus and you were messing around with it. They don't help with that at all. They just expect you to have one of those.
So they connect. They spin up a Heroku database automatically when you use their cloud version. But on their open source version, yeah, you kind of have to set up your own database. They support Postgres. I think they're going to support MongoDB in December or something like that. All of the relational databases like SQL, they already support, I believe. Yeah.
Cool. Does anybody want to ask Kyle something? You ask me, I ask Kyle, he answers. No questions, Kyle.
It's all good.
Yeah, okay. What's the competition? What's the competition for Hasura?
AppSync, AWS AppSync, which it is a very similar service. So, but I believe they only do DynamoDB, which is an AWS thing as well. So AppSync is essentially a Hasura without the cool UI. It's all in the AWS console, and it's kind of a pain to work with. Hasura is nice because it works with any provider and any kind of source. But AppSync is a way that you give it a JSON. I forget what the JSON-based databases are called, but a JSON-based database, and then it'll automatically create a GraphQL endpoint for you. I'm not sure on other competition, but Hasura is pretty great.
So it's the glue between your database and a front end. Yeah, is that?
Yeah, exactly. It's the middle layer. Like, any Rails, it handles the ORM, the business logic, things like that. Yeah, I don't know of any like super large. I'm sure on their website they show like all of the companies that are using them, but I can't think of any. Like, you're not gonna find like YouTube using Hasura, right? Like, but I'm sure there are like decently sized projects that are using it.
Right, and then if you're building a front end, you'd still need a GraphQL client, right? You'd still use React Query or Apollo or something.
Yeah. So any client-side application that has that parsing for you, can interact with it. There's no, it's agnostic. It just handles the parsing on the server side.
Cool.
Yeah.
You asked me, and I asked you.
Does it handle the case of, like, I have a client over here that's interacting with some shard in the cloud, database shard in the cloud, and makes some change, and that change will get propagated to like all of the other clients in my app space? Is it?
Yes. Yeah. So there are. It has subscriptions, so it's you can still do WebSockets through. I don't know. To be honest with you, it's been a couple of years since I've dealt with database sharding, so I'm not super up to date on it. But I will describe to you subscriptions, which are it literally just opens a WebSocket, and as opposed to just doing a query. And whenever a column value changes that the client is watching, quote unquote, then the Hasura instance or the middle application layer will send a notification to the client side and say like, hey, this value has been updated. Now update your value. So it handles WebSockets and connections like that. I don't know if that answers your question, but
it's not the client side so much as the server side is where that's challenging. Like when you have multiple, like when your database is like sharded in the cloud, you've got multiple instances running, with data spread out. So like if you change it on one system, it doesn't necessarily, like that's got to get propagated out to the rest of your architecture. I'm wondering how, like, if it addresses that side of things. I'm not sure I'm articulating that well.
I understand. I'm not sure. I can't answer your question. I don't know, as the answer I'll give. I don't know. Yeah. I do understand what you're asking. I'm just not sure how they solve for that, or if they're even worried about it. How?
Right. And I'll have to look at this.
It looks cool. I wish I understood it better because it seems like you still got to write your own schema. You still got to write all your own type. It's like all this effort that you still got to do. It's like, what are you doing for me again?
I think the benefit is that you get to fire the backend developer on slide number 1.
You fire the backend developer, Kyle.
Well, so the biggest benefit is like, so in data engineering, like I've done a lot of like data engineering type stuff where you're just dealing with like APIs and calling from third-party services and doing stupid database transformations all day long. And like if a PM or product manager, or you want to provide an interface for a developer to work on a database, and you don't have to spin up a Rails service that provides all of these like endpoints that are basically boilerplate. Like all you have to do is give Hasura a database URL and it automatically emits an API for this entire table. And so it just saves any kind of development lifecycle process where you're like, I just want someone to be able to consume the data that's in this table immediately. So that's a huge benefit. And it's I couldn't hear that. Sorry.
It was an amazing comment. That was super relevant. We got to wrap it up though, because we got a bunch of more speakers. So thanks a bunch.
Yeah, no problem. Cool. Thank you.
See you later. Woo!
See ya.
So how are we gonna do this? You give me this.
No
I'm gonna
idea.
go like this, like
I don't even know
this.
how well this will share. Oh,
Oh, it's
it
gonna
does.
share
Fine.
amazingly. Share screen. Oh no. iTerm? Get out of here. Share this one special thing. Maybe it's that
How
one.
about browser tab? Put that tab in your window there. That's-
Crap. Share screen window. Which one is it? This one? Because it says we must go bigger. Why isn't that available? Oh, Chrome tab. We must go bigger. Why is that not available? Oh, it's because this is open in freaking Canary. Dude. I can't. Why did I do that?
Grab the link and put it in there.
I'm going to just open a Canary tab.
There you go.
Then share it.
Yeah.
Chrome has lost permission to capture your screen. No.
Would it be easier if I just joined from my laptop?
Yeah, probably.
Cool, that way it's not sliding wrong, I'll edit on the fly. Not that there's any much wrong.
So you just present up here with this link.
All right.
And I'll just keep broadcasting over here.
Okay,
That means, though, you have to click that link I sent you in Slack.
I can do that. I'm capable of clicking the link.
Really?
I don't know, are you gonna like steal my identity and shit?
I barely even understand computers, so probably not.
That's okay, we should just all go ride our bikes. There we go, entering a broadcast.
There you
Let's
go.
see. I guess I should allow. my
Yeah,
internet
just give it
access.
all kinds of permission.
Sure, you own my soul. Mic is working, but I'm gonna still mute it so it doesn't like do a weird echo.
Okay. I think it'll be okay because I won't.
And now I unmute.
You should unmute.
All right. Is there anybody else listening?
But you don't have to look at yourself. Just I'll take it from here. You have
Okay.
to share your screen though with this.
Well, then I will share screen.
It's probably gonna be like
Whatever.
you didn't
Share
give it
screen. Chrome tab. Bam. Share.
Nailed it.
Bam. Look at that, yo. Wait, I don't need to do that. I want to do that. All right. Can all them remote folks see all good, yo?
Yes.
All right. Cool. How's everybody doing tonight? All right. Yeah, can Kyle at home hear me okay if I shout? Ask him. All right, cool. Well, while he's asking, I'll do my brief intro. So my name's Brian. I'm an SRE over at Twitter at the Ye Old Birdhouse. I've been making my bread and butter about making small services get bigger and handle more traffic and generally be more stable. Yeah, so that's what I do, and I thought I'd throw together a really fun, simple, easy talk that kind of like draws through some of the thoughts and philosophies behind like what I think of, and it's going to be real easy because the entire talk is all based in emojis. So you made a web page. Congratulations, awesome. How cool is that? Now, what happens when you start showing it to people? Hey, they see your web page. Wow, that's cool. They tell their friends. And then all those friends go to that web page, and what happens? Shit slows down because, it's generally like one computer back there that's trying to serve to like, I don't know how many tens of hundreds of thousands of people because, you made something that cool. So what do? What's the next action? Now, usually, what's the typical next action? You say, okay, I've just got one little service. I'm serving to too many people. What's the usual next action? Anyone? What's that?
Services.
More services. Bam. Scale it out. Everybody's happy, right? Because everybody gets to go, hey, I get to go to this one computer that's serving just to me, right? Special.
But then what happens if they don't all go to the right fan out? Everything gets all crazy and jumbled. A few of them just get really slow. And, then you might have some happy people, but then you have some other people who are saying, why does this shit go slow? What the hell? Refresh, 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 and then they're crushing this thing. Now, what else is missing from this picture? What would be the next action? What would load balancer? Bam! 10 points to Gryffindor. All right. What's that?
He's a plant.
So who knows what a load balancer is? Shut up. All right, a load balancer is basically there to be kind of a reverse router. It takes traffic in and it has logic that used to say, all right, you're not taking any load, I'm gonna throw stuff at you. It does it either randomly, round robin, really fancy, expensive ones, like at the book face. I see your shirt there. I used to work forever ago too. We'll tell stories later.
Okay.
Some of them can work in feedback loops. That way the servers can then put back pressure up and say, yo, I'm too busy, go somewhere else. And then the traffic goes somewhere else. When you're serving to a pool of like 10, 20, 1,000 nodes on the back end, though, it generally doesn't matter too much as long as you're fanning out evenly. Cool. Now, this is a neat little, and also a lot of cool load balancers can do things like Terminate Ssl. And that becomes handy because then your backend servers don't take as much load about doing individual user auth. So that's kind of cool. Now, this is where I simplify and say, all right, we don't need to worry too much about everything that's coming into the load balancer, because once you're behind the load balancer, it's just blind traffic, right? But, if you're making a cool web page, your cool web page isn't just going to be static. It's going to do some smart stuff. It's going to have let's say it's a shopping site and you've got a cash register there that you're selling, or inventory. So you've got items for sale that have dollar values that go into a shopping cart. And then you have sales where you can knock off 20%. That stuff needs a database, right? Cool. So we're throwing a database in because we want more functionality. Generally, this is what happens once you get to a certain point. You have to add functionality to make your site go burr. What happens when that database goes slow? What's the next thing? What are we missing from this page? Anyone? What's that?
Replication.
Replication. Bam. Oh, yeah, because, when you also, I missed more words here. If you have one site, one host, not only can it get slow, but you could have catastrophic failures because all your data is in one place. Hence replication. Replication's awesome. Well, we talked briefly about it where, you write to one place and that one place synchronizes out. MySQL and Postgres do that. I don't know anything about MongoDB, so I can't talk to that. Hadoop is the whole point of Hadoop is to be able to replicate literally everywhere. It's crazy, although you don't have a single master going on. You have a whole bunch of other databases where their whole architecture and infrastructure depends on taking one bit of data and fanning it out to a bunch of places. Cool. So for my diagram purposes, I kept it relational. Single write master, multiple read replicas. Cool. And we simplify that down. What's that? Cool.
Talk there.
Yeah. Oh, man, you're putting me behind the podium. I feel like I'm in a box now. What the hell? All right. Cool. All right. All right, cool. So from now on, we know that one icon really means a group of databases, and that one icon means a group of web servers. Now we're going to talk about even more scale. What's the next step from here? How do we get bigger from this? What happens then when it's not just one database, but the entire set of databases, everything is slow on the back end? What's the next step to do? How do you try and make things faster for your front end? Cache it. Bam. 20 points to Gryffindor. So I didn't know what a good icon to put, so I put in cache. Hey, serve it out of memory. Fast, lightning, super awesome. Cache is also conveniently expensive. Hence, cache is an appropriate name because storing in active memory large amounts of data costs lots more than storing just on disk. And, Moore's law aside and all that. But caching is good for storing reads. So if you're just reading, a username out of that web page a million times a day, sure, store it in cache because that's not likely to change. But what if, you're serving, like billions of tweets per minute that get written in, all of that right through coming to a database? That's insane. How do you scale that up? If every load of the page writes something out, how do you funnel that in such a way so that way you're not taking down your database?
Build a queue.
Build a queue. 20 points to Gryffindor. All right. But the other thing before you build a queue is you partition out applications on the back end. This is where you start saying, hey, that one application is not good enough necessarily. So you split it up and you say, okay, cool. Well, let's scale up reads and writes independently in separate physical logical applications, because those may have just been discrete functions in your base app. Now you partition them out and you say, okay, all reads go here, all writes go there. And you may also expand that functionality in other ways too. And then, of course, when all those writes start fighting for database access and trying to write in, then you put in a pub sub queue and you line it up. So that way, everything goes through smoothly one at a time. Your front end that handles those writes can hand off to your pub sub queue. Maybe anybody not know what a pub sub queue is? It's okay. Cool. Publisher, subscriber. So it's just a pipeline where data goes in one end, data comes out the other end. And it's meant to be just like quick and dumb. So you say, hey, here's my write blob, and it could be something like, a structured JSON or thrift blob. It could be a SQL query. It could be whatever it is, because you're inevitably going to have some. I should have put another block behind the pub sub queue there.
I take issue with that description for a moment. It's not so much a pipeline as sort of a fan out, right? Like that's really what pub sub gives you.
It's logically a pipeline, but physically, yes, it's a fan out. Because you have multiple ways in and multiple ways out, and then you have application off the back end that peels off. But everything does intentionally get lined up internally, and you're peeling off the back end. It depends on what your scale is, because you can have a single pub sub queue that's like in one application. You could use RabbitMQ as a singular, Celery as a singular, and not have to fan anything out. So, satisfied?
Sure.
Tell me I'm wrong, please. This is meant dialogue. I'm all for dialogue.
No, yeah. I mean, it's we can get into the sort of the rabbit hole of what pub sub queues are used for.
Right.
Yeah.
Okay, cool. We could argue over beer later. How's that?
Yeah.
Cool. Like it. All right. But yeah, logically, all it is that it's there to just handle your transaction for you so that your front end application can say, yay, I'm done, and just hand it off to the pub sub queue. All right. But then, okay, reads are getting slow still. You've already scaled the hell out of your database. You've already scaled the hell out of your app. Where's the next place to go from here?
Subscribe to your pub sub with your cache.
Well, that's one thing, but this is where you have to start getting tricky with what my simple rudimentary pile of emojis here is going to be able to demonstrate clearly. This is where you have to start saying, okay, what functionality in my app is actually getting slow? Because then you might what if you're like scaling up 10,000 expensive nodes, but it's really just one function call that's slow? That's when you do things like partition that out. Like if you have something like a search function, search functions are inherently expensive as opposed to just like a simple retrieval function. You're generating highly expensive queries. So you might replicate your data set off to a different database that's more optimized for query load, for search load, just index it differently. Maybe it's a completely different DB product. And then you put your search infrastructure on top of that. And I use that as an example because you can then start looking at your base applications and peeling off different functionality into different verticals in your application. Now, you can go down the rabbit hole from here, but I kind of want to just share this because these are the kinds of thoughts that I think about when I do my day-to-day as an SRE. I start looking at the application. I say, where's the tight spot? Where's the sore spot? Where's the bottleneck? How can we make this work better? recently, well, not so recently, this was one of the things that I did at my current platform that I work on. When I came on the team, they had a 3-tiered stack, and they just had a finite set of physical hosts. And each physical host had all 3 applications, none of which needed to be co-located for any reason. They just said, well, let's just make them all the same. So I worked with them to move them onto an internal containerized platform that we use at Twitter. Yes, we use Mesos. It's not Kubernetes yet anyway. And the idea then was that we could scale up each of these 3 services independently. And then since they were containerized, they could stack within their hosts. And so these are the kinds of things that you think of. You say, okay, where's the problem? And then what tools can I pick up in order to assemble our service differently to make things better for our product, for the teams that we work with, for our customers at the end of the day, and for everybody as a whole, So I am a shit programmer at the end of the day, but I'm pretty good at being able to do this kind of stuff. And if you're pretty good at it, I want to hear from you. So yes, we're hiring. Here's my quick plug. So there's my recap. Yeah, step back and look for where your bottlenecks are, do your monitoring, and use that to kind of like guide your decisions about what architecture changes you make. Applications, ideally, you want to try and get to like one function to one service. Now, when I say function, like, a single, private static type thing, but like single functionality, like a search function. That's like a product stack on its own. That could be a whole service on its own. It doesn't need to be nestled into your service when you get to that scale. Know your databases. I'm not an expert at databases, but I'm pretty good at being able to understand what database functionalities meet the needs of the services that I'm working with. So that's more or less my blab for the day. So. All right. Thank you. I'd ask if there are questions, but again, this was just kind of like, blabbering and space filling. So I'm just happy to be up here.
Twitter. Where should I start?
What's that?
I want to DOS Twitter. Where should I start?
Oh, we have talks. We have some talks. All right, cool. Let's do that. All right, I'm going to hang up.
Yeah, all good.
All right, cheers.
Look at this fucking technology. It's incredible.
Technology world.
So you're going to look at my face for a minute. I guess Robert's going to go next, right? You've been working on the...
Yeah, I'll just go off my laptop.
Yeah, well, I'm going to send you a link then. On Slack. You got your Slack open?
I should. I do.
Just send it. Piece of shit. Paste.
Because it's running first before I plug in. Am I not?
Oh, I see why. Yeah, StreamYard.
Okay.
Hi, if anybody's watching. Just doing technicals with my fingers. We're going to have Robert next talking about unique identifier descriptions. That's what they're called.
Come on. Where everybody's doing like the something guy.
Yeah, you win. I don't have a thing.
All right. Is it mirroring? No, it's not.
I got like thing, like a famous NPM package. All right, stream. I'm gonna pass it to.
How do I mirror this? Arrangement, mirror. There we go. All right. There we go. So I just need to share here. Let's see, Leave Studio, where do I share it?
Once you've shared, you can do it. You can minimize this StreamYard. It doesn't matter.
Where do I share it? Mute, stop, share. There we go. Share screen. Screen share. There's 2 monitors. Screen share works best.
On a good computer. Use a good computer.
Sure. I'll share my whole screen. That'll work, right? Are we going there?
Stream.
Okay.
And then just get rid of StreamYard. Forget it's even there.
Okay. All right.
Is there really a spec for Uuid?
Oh, dude.
What?
All right. I was telling people earlier that I've been meaning to give this talk for 2 months, and so I started prepping for this like 2 hours before this meetup, and then met my kid for yogurt at frozen yogurt at Cup of Yo, and then had my laptop crash. So you're going to get what you pay for with this presentation. I appreciate that. Thank you. Okay, so state of the Uuid again thing. I'm Robert Kiefer. I happen to be one of the maintainers of the Uuid module in NPM, which I'm fond of telling people. So many of you who know me have heard this many times before. It's something I sort of happened into years ago by virtue of needing a client-side unique identifier, because trying to figure out how to do data synchronization between client and server is fundamentally a difficult problem. And if you can have your clients generate a unique ID that is, unique across your architecture, and you can avoid going back and forth to the server to figure out whether or not it's actually unique or what the server thinks the unique ID should be, you dramatically simplify your system architecture or the client-server interaction. It's just a great thing. And it's so good that it's actually there's a spec for it that was defined in July of 2005 called RFC 4122. And the history of this actually goes back to the 80s. Like this is not a new problem. Data synchronization in a distributed system has been around forever, and various companies have been doing it. But the first real RFC, like industry standard, emerged in 2005. And I happened to stumble across it while trying to figure out a solution for this problem, and it was right when Node came out, and NPM was sort of a new thing, and I was like, oh, I'll just throw this out there, and it gained traction, and now the Uuid module is downloaded like 250 million times a month off of NPM, which is cool, and also another bit of data I'd like to put out there because it's cool. In the process of maintaining this, which I did a poor job of often, I sort of got to know a few other people, got them involved, and it is now a Uuid JS project on GitHub with like 4 or 5 maintainers, and it's a whole thing. It's been around for 10 years, and for most of that time, it hasn't changed all that much, but there's been some activity recently that I wanted to talk about. And I wanted to just sort of give an overview of, basically do a recap of Uuids for those of you that aren't that familiar with them, and talk about the different versions and kind of what the thinking that's been going on around like where Uuids are going. So first of all, this is what a Uuid looks like. It's 128 bits. In string format, it looks like this. It's 32 hexadecimal digits with 4 hyphens in specific places. You can have any digits in there you want, except for the 4, which specifies what flavor of ID is contained in there, and we'll get to those in a sec. And the A letter, which can actually be 8, 9, A, or B. It's basically, there's 2 bits in there that need to be set to indicate that this is actually an RFC 4122 ID. Other than that, you can have anything else you want. The Uuids are useful. As I mentioned, generating 100% guaranteed unique IDs is a difficult and complicated process because you have to do all this round trip to some sort of central authority that can say, yes, the ID you have, whatever it looks like, is known to be unique to me, and I am the authority. And it's it doesn't scale well. It's just a painful process. If you can come up with a scheme by which you can generate IDs uniquely in a standalone client that are known to be sufficiently unique for your purposes, then that problem gets a lot simpler. So RFC 4122 solves this problem in various ways. And the uniqueness guarantees that it provides are actually quite good. So if you generate two random version 4, I'll get that in a sec. You generate two version 4 UUIDs, the probability of collision is 99.99999 out, like another 30 decimal points. It's like there's an incredibly large space there. It's 2 to the 126th base, or 122nd, sorry. And to give you an idea of like how that holds up as you generate more IDs, if you generate 3 trillion IDs, which is a lot, like even for large companies like Facebook or Google, you have literally a 1 in a million chance of there being a collision anywhere in that space. So it's a pretty good algorithm, and it holds up well. They are also difficult to guess. It's just one of the properties, but at least version 4. But the spec says don't assume that they're hard to guess. So, they get used for security tokens, not security, but obscurity tokens. But it's not actually good practice to do so. They are widely used. You will once you see that particular incantation of UUID string, you'll start seeing them everywhere. You see them as database keys. You see them as like API tokens. You'll see them as device identifiers. So in my previous company, we had IoT devices that had a UUID assigned to them that you actually used in the fleet management tool that was available online. I've seen UUIDs on like Home Depot receipts, and they're like all over the place.
I've seen a UUID on Home Depot.
It was, or maybe it was Best Buy. It was like for like a an extended warranty thing or something. So anyhow, they're all over the place. They're supported in basically every programming language anybody here is likely to care about. Many of them have native support, and the ones that don't generally have third-party support for like the UUID module. I didn't. Did I kick something? Are we back?
Reshare your screen in StreamYard.
This is monitor. All right.
But it died in StreamYard. So can you reshare?
Oh yeah. Can I? Yes. Share screen. Share. There we go. Are we back?
You're good.
Okay. All right. In JS land, it's the UUID module that like I said, I help maintain.
So which module do you maintain?
The UUID module. Thank you for asking, sir. So you'd think I get paid for that for some reason.
I actually am a consumer.
So here's the thing. Pretty much every device in this room that's got a decent sized CPU on it is probably running the UUID JS stuff in some form or other. Okay, so brief aside, I had lunch once with some of my coworkers, and I was like, "Why do you guys program?" I thought everybody would be like, "Well, we really like people using our code," which is my answer, and I got a whole variety of answers. It was a really interesting conversation. For me, like one of the things that sort of like strokes my boat or whatever I don't know what the term is, but one of the things that sort of like motivates me to program is I like seeing my code used. And so having something like this out there that that has a lot of traction, that that has a sort of a broad industry influence is kind of cool. It's there's a whole conversation to be had around like why people code and how standards and open source and all that play into that. Be that as it may, let's see. Oh, hey, I should probably actually play this. So the thing about RFC 4122 UUIDs and what kind of makes this talk industry is that there are different flavors. The RFC specifies 5 flavors. Version 1 is time-based. It has a timestamp incorporated, encoded into it. Version 2 has a DCE user security token encoded into it. Get to that in a sec. Version 3 is based on a namespace ID. Version 4 is random, and version 5 is also a namespace, just with a different hashing algorithm. The reason why I wanted to revisit this is that there has been some conversation around the pros and cons of these different flavors that has sort of that is starting to influence the direction that that APIs and the future standards are going. So let me just recap those. I have no idea why I have 2 slides here. So DCE security version, version 2. It has a DCE user security attribute. DCE, I don't even remember what that stands for, but it's this industry consortium that was formed in the early 90s, and that was then incorporated into the open source federation and then the open group, and it's gone through like 4 iterations. And I actually can't find a definition of what a user security attribute is anymore. And nobody that I've ever seen uses version 2. So this is in the spec. It's basically useless because it's just, I'm not even sure it's relevant anymore. Version 3 is a namespace ID. One of the big problems is it doesn't actually solve the uniqueness problem. You give it a namespace and a name, and it turns it into an ID. So it's just a hashing algorithm. In this particular case, it uses MD5, which is these days is considered a broken algorithm, and it's only mentioned in the RFC because it has there's sort of legacy reasons for it. And the RFC actually suggests that people not use it unless there is some backward compatibility reason. So that one's kind of off the list as well.
DCE stands for Distributed Computing Environment.
Great. Can you tell me what a user security attribute is?
No.
Because I have no idea. But it's somehow it somehow gets encoded in those bits as like the low order timestamp bits. But there's no I can't find a description of what the values would be.
That makes sense because that similar functionality is baked into X509 service.
Okay. Again, a decade of doing this, I've never seen anybody with a version 2 ID. What's that?
Hardware token, like your Bluetooth drive, would be like a prefix to your time base.
It's going to be encoded. It's going to be encoded as like 14 or 16 bits of data. So it's a number, and it's not like just bit flat. I don't know what it is.
Yeah.
So I haven't been able to find out. So I'm sure it's probably somewhere, but my interest in finding how a version that nobody is using works is pretty minimal. So version 5 is the other flavor of namespace. It uses SHA-1. Again, doesn't really solve the uniqueness problem because if you want unique IDs, you have to give it unique inputs. In this case, it uses SHA-1, which hey, better hashing algorithm. And actually, I forgot to mention that on version 1 version 5. Okay, so this is used, but only in about 1% of the cases that we've seen. So one of the as I've been working with the other folks on the Uuid.js project and some of the API standardization that's been emerging from that. Christoph, the guy that maintains that's really the lead maintainer now, ran like a big query across the Google GitHub data set. So hundreds of thousands of projects to see how are Uuids being used. And he came up with statistics on the relative popularity of these different versions. And namespace, and particularly version 5, is used in about 1% of cases. So it's used, but it's in very limited ways.
Well, what's popular, 4 and 1?
Yeah. So the next one, version 1, is used in 10% of cases. So version 1 is the timestamp based Uuid. And when you think about hey, I want a unique identifier, you're using a timestamp is actually a pretty common solution to that problem. Unfortunately, there's a few issues with it. One thing is that the RFC specifies you should incorporate the MAC address of the current device that's generating these. Back when the spec was written, that was assumed to be a fairly unique number. So, if you have a device that's got a MAC address, like, okay, we'll put that in there, and that along with the timestamp will give you a fairly unique value. There's a couple of other fields in there, like a clock sequence and a node. Well, actually, the node is the MAC address. The problem is that MAC addresses aren't that unique. I mean, for starters, you can clone them and duplicate them, so that's sort of an issue. But the other problem is that cloud services where you're running containers, like some of those have consistent MAC addresses like across the board. So you can have an entire fleet of containers that are all generating the same or generating UUIDs with the same MAC address, which is like 48 bits of that 128. So you lose a lot of potential uniqueness in there just in that problem space. And as such, the uniqueness guarantees that come with version 1 are questionable. And we'll just sort of leave it at that. But that questionable is like, many orders of magnitude from the last one, which I'll get to, which is version 4. The other thing about version 1 that kind of pisses me off is it uses an epoch that is just bizarre. So the timestamp in version 1 is the number of 100 nanosecond intervals since October 15th, 1582. Now that's the Gregorian epoch, and yes, it's like, what the fuck? Like, why are we doing this?
Does that have anything to do with like that's the first number where like in binary or in hex, whatever, you finally have filled enough bits that aren't just zeros?
Well,
if you're say starting from standard.
It's basically because that's the epoch that Microsoft used for their file system back in the day. And Microsoft was one of the primary contributors to this RFC spec. So, but if you want to represent today's time in to 100 nanosecond resolution, you need something like 58 bits to do that. And JavaScript numbers are IEEE 755 floating double precision floating point numbers, where there's only 53 bits of significance. So you can't actually represent these timestamps accurately with JavaScript numbers. You have to use 2 numbers and do some weird bit fiddling games, which is one of the reasons why if you're doing version 1 UUIDs, you should use the UUID module. It's like it deals with all this sort of niggly-piggly shit. But it's been a thorn in my side ever since I first stumbled across this issue, because it's just like, why? So that's version 1, used in 10% of cases. And then the last one is version 4. So the main issue that you have with version 4 is if an implementation is based on a poor random number generator, your uniqueness guarantee drops dramatically. And we actually had in early versions of the UUID module, we had people saying like, hey, I'm getting collisions. And my reaction is like, that's fucking impossible. Pardon my French. But it turned out there was a bug in math.random in early versions of Chrome where like if you spin up Chrome and start calling math.random, you would get the same sequence of numbers. And that was actually like one of the CV. We got a CVE security issue filed against Node for that, which is why we no longer use math.random. So, anyways, the version 4 is what 90% of the use cases have, and honestly, those other 10% or 9% for version 1, we reached out to like a subset of those developers and like, why are you using this? And like, well, we don't really know. So it turns out most use cases could use a version 4 ID and nobody would be the wiser. And sort of our advice is these days, if you need a UUID for something, use a random UUID. So yeah, unless you prefer something L. Sorry, typo at the end there. So that's kind of the current thinking on what's in the RFC, is really like most of the versions there don't actually solve the uniqueness problem well.
And unless you have a reason to use version 1, then stick with version 4. This conversation, sort of all this, it really came up in the context of a conversation that was started by a guy named Benjamin Coe at Google when he reached out to the Uuid.js project and said, hey, we're looking at adding a standard module feature to the JavaScript language where you can actually require like standard colon and then some number, and that will be built into, that will be expected to be available in all JavaScript contexts. And we'd like Uuid to be the first one. And so it was, basically it was like, how do we turn the API that Uuid offers into a standard part of the language? And I'll make a long story short by saying the conversation that ensued from that was slow, because such conversations tend to be when people are distracted with jobs and other things. And it was also complicated by the fact that it didn't really have a home. It started out in the context of TC39, which is the organization that really shepherds the JavaScript language itself. But they didn't really want it to be part of the language. It was really more like, how do you have standard modules that sit off to the side of the core language? And so we ended up in the whatwig. But then we had an issue of well, if we want to specify this, we really need to guarantee that there is a random number source, of a high quality random number source available. And so we were like, well, let's add math.random bytes to the core language, and got pushed back on that. And eventually we landed in the WICG, which is the Web Incubator Community Group. It's sort of a subset of W3C. One thing led to another. We actually have a spec now that's at this URL here. So if you want to see what the Uuid spec looks like, you can go read about it there. I'll give you the short version, which is it's crypto.randomuid. And if you're going to implement that anywhere, use a high quality, a cryptographically secure, that's sort of the term of art, use a cryptographically secure random number generator to ensure that you are getting high quality randomness. So that came out in August, and you can now go into, hey, demo time. You can now go into, here's the spec. And if I go in, so we're running in Chrome here, and if I go in here, and I go to console, come on. And I make it big because I like big. And I go to crypto.random Uuid and spell it right. And really spell it right. Hey, you get a random ID. And let's see, can I do it here? I'll do it again. Node. Require crypto.random Uuid. So that's what I'm excited about, is that this stuff is now becoming available by default. You don't have to require my effing module anymore. And I can quit telling you how many times it gets downloaded every month. So that's sort of for me, that's the exciting part. I have one more slide, which is, go back here, that other people are thinking about this problem space. So there's a Uuid version 6 project that's in GitHub here. It's an active conversation about what do we want to be doing about version 1 IDs, because they are useful, but not in their current form. So so basically there are people that are out there okay, we want timestamp IDs, and the problem that's really driving this is that if you have a time series database and you want to be running queries against that are indexed by the Uuid, because that's what you're assigning to these records, you want those records to be localized so that if you search a specific subset of time, it's all in the same spot. It's all in the same file system shard, and that helps your performance. The problem with the current RFC is that the bits of that timestamp are in the wrong order. The volatile bits, like the second and sub-second interval data, is at the beginning of the Uuid, and which is where the index, which is where the sharding tends to happen. So so the sort of step one is flip the order of those bits so that the database locality isn't so problematic. But they're also revisiting this space, and there's a bunch of other issues. So the new timestamp epoch is probably going to, well, it's going to be a Unix epoch that starts in 1970 instead of 1582 or whatever it was. And it'll probably be either second or millisecond time intervals. And then there's some other stuff in there, like the whole idea of MAC address is out the window. That's just terrible. But they're revisiting other things like how many bits do we want? Do we need more than 128 bits? Maybe 160, maybe more, maybe some arbitrary length. And they're also talking about string encoding, because the string encoding is not as efficient as it could be. And these strings do tend to be a little long.
Like there could be emojis in them?
No, but Douglas Crawford of JavaScript, the good parts fame, and also the guy who invented JSON, turns out to have published a base 32 character set. So where hexadecimal, each character represents 16 bits, the base 32 represents 32 bits. So you get you basically save you get an extra bit per character that you're representing. So these strings get a little bit shorter. And this is actively being developed now. So if this is something you happen to care about, and like honestly, like even I sort of checked out of this discussion a little bit because it tends to be dry, and database locality isn't really an issue of high priority for me. But if this is something you're curious about or want to participate in, it's happening now. Like there's issues that are open. You can file issues. You can jump in and give your 2 cents on what you think UIDs should be and why they're used and whatnot. So I'll stop there. And if there's any questions, I'm happy to answer them. So.
How many did we download?
220 million. Oh, 2 million weekly. Is like 50 some.
It's 42.
42. It is a lot. So it's mostly because it's been around forever, and it's used in like thousands of projects.
Yeah.
So
Robert works at CodePen now? Just saying.
What?
That's right. It's awesome, and we're going to use UIDs all the time.
I'm not pushing the UID for CodePen. So, all right. Thanks, guys.
Do we have tolerance for like CSS crap? Like we can pause for a minute because I have to anyway because I got to pee. But like, I'm gonna rapid fire this. But like, why is it doing that? Oh, I know why. Just gotta turn that. I'm sharing my screen, right? Why can't I turn down the sound? Let's not worry about it. I need to turn this off, this thing. God dang it. 42, only 9 million a week. They were talking about it. They were talking about you on YouTube.
Wait, what?
Then I'm going to remove you. I'm just going to point this down. We're going to take 5, and then I'm going to tell you about CSS. I promise you what I'm going to tell you about CSS. Nobody knows it yet. I overheard some conversations literally today about future CSS stuff that's.
CSS broke me, that's why I went back on shit.
There's 2 new pieces here, and it's a 2 credit minimum tonight, and they're free.
Where's Kyle trying to fire off back?
Yeah, look at that.
Right. You are
Dave, you're supposed to use the correct statement.
What? Yeah, it's a lot. We do rentals. Yeah. So, yeah, no, I it's the first like
What are they?
job that I had.
As long as my largest things without 10 days. Probably not single. No. Because, well, that depends on like what you're storing. Yeah, I mean, I don't think you're multi-terabyte disk drives out there. You know, if you have a Facebook account, you're on multiple discrete MySQL databases out there already. Google did three locations. But I think back there's something largely distributed like that. There's probably
So what kind of yeah, they've since expanded their
well, database product.
What's up, David? You gotta go, or are you gonna listen?
One thing to say, okay, we migrate to Sharp.
See you there.
Some container stuff? Going from why, that's a whole
Somewhat.
different.
Yeah, I'm gonna.
Chat about container queries.
No, it's not even on the list. There's 5 crazy things in CSS, and that's not even crazy enough to make the list.
Container queries? Crazy?
I'm telling you.
No.
Privacy.
Funny, you pulled that up. I saw that.
this was like
I saw that post from Ben today. Calling it.
I got a shout out on CSS tricks.
From who? Oh, from Ben.
Nadeau.
Oh, I like that guy.
He's the dude that learned Cold Fusion from, man.
Oh, really?
Yeah.
Nice.
Old school, man. Like old school. It's like 2005, dude.
So I can't even share my screen because the stream has lost permissions or whatever. Fuck. See that? And if I refresh the screen, see how it's live streaming to YouTube right now? I think if I hit refresh, it'll just kill it. It'll like kill the stream on it. I don't think I have much of a choice though. So privacy, screen, yeah, I don't care. But look, it's already, oh, because it's not Chrome, it's Canary. Fuck. Well, because I have to, because I was showing you all this crazy CSS stuff. Yeah. See that though? Streamers, I just got to do it. I got to.
We went through this.
Oh, we're still streaming. We did this successfully and didn't screw it up. All right, just bounce back in. It's probably because Kyle's still in there. Thanks, Kyle. Share.
And just statically serve. That's it.
No. Where's my? There they are. I'm gonna put it on this mode, and just forget it. All right. I'm just gonna do this really quick. 10 minutes of stupid CSS stuff. I'm gonna drink my way through it. What I promise you though is that this is some new shit.
New shit.
And CSS is like on fire lately.
What?
I know it's weird because it's like even when it's moving fast, it's still pretty slow in the technology. Okay, here's the least weird thing is that even the W3C is pretty proud of this one. They made it one of their news items that there's going to be nesting in CSS. Not that weird because SAS has had it for 10 years or something, but it's a little interesting. What? Less? Less is, I will diss less. Less is less. What a shitty name for a processor. It's less. It reminds me because Norm just died, you know, and he said, at number 2, better than Ezra. At number 3, Ezra. You hear that Norm Macdonald joke? Fuck, that's funny. So this is not SAS. If this was SAS, I could turn on SAS. I can fucking nest all day. Card, title, easy. Color red, that's gonna work. Because I have a title that's within a card. But if I turn CSS off, that's not going to work. Now, this does not have any implementation yet, so that's just not going to work. But should that work in CSS? Like, would you vote for that working in CSS? I would. That's nice, right? They're not going to do that, so that's not happening. What the spec for a while has been, including this one that's published, is that you have to use that thing, which is fine. That's how SAS works too. SAS has that as a token where you put that. You don't have to in SAS though. It's implied in SAS. It's not going to be implied in CSS. You have to put it. So that's cool. It's just that if any selector starts with it, they're saying that's cool, but like if you put it over here, like let's say you do like body.dark theme and, you know, have you seen that kind of crap in SAS? When you put the selector later, it fucks up CSS somehow, so you have to do this. You have to say nest, and then it'll work. And this in this new features in this spec, right? So we'll scroll down the spec.
So what does it mean if you just have a nest
Like you,
without these?
it just fails. It just won't work. It's some kind of infinite look ahead problem, and it fails. Why?
Probably your dongle. I have this problem.
I got to reshare in StreamYard quick.
So it's really useful, and also things that you need to bring up out to a parent.
Where's StreamYard?
So it looks good.
Yeah. So in other words, if this thing is.
Yeah, but like I don't have a tab for StreamYard. Oh, there it is. Oh, you're right. I'm sorry. All right. So you get that, how it has to have the ampersand. You don't have to have a space after the ampersand. That will just line it up right next to it. Foobar, pretty cool. You can put the ampersand multiple times in there. That's pretty handy. You can put the ampersand, you can double it up, foo-foo. They say it's silly in the spec, but that's just a cheap trick for increasing specificity, so don't hate it, you know?
That's confusing.
Well, a little weird, but like it's a token for the parent selector. I don't think it's that complicated, really. One up only, I think. But who knows if that stuff will change? Because here's a weird one, right? Where it's bar, then it'll be bar dot. It's saying this isn't cool, right? This is not a simple selector, whatever that is. It's because the ampersand is later. When the ampersand is later, then you got to use that @nest thing, right? So it says if the ampersand comes any later, then you got to use @nest. And so I bring this up because somebody DM'd me today. They're like, we talked about this. We all got together, our little smart spec people, and we fixed this. Because personally, I hate that. Like, I think that's silly that sometimes you need nest and sometimes you don't. That's weird to me. So they said, this is how we're going to solve it. Like this. Card, wait for it. Oh, double brackets. Now you don't need one at all. You don't need an ampersand at all for simple selectors. And if you want to use like body.dark and rock and roll. I don't know if that's going to ship, but that's super weird. And nobody in here knew that, I guess. What?
You're already wrapped. That's not going to cause bugs.
Well, it'll be weird. And it'll cause all kinds of syntax highlighting bugs, I think.
Like, can you have white space between the brackets?
I don't know. Yeah, can you get weird? I bet you can. I bet that. I don't like it, but I bet somebody's gonna have to write a prettier rule right away to fix that. Anyway, this is new as of some spec people rewriting some spec today. So is it gonna ship like that? I don't know. I just wanted to show you because I heard it and I thought it was cool to share, right? Okay, let's be done with nesting. There's already container queries. I told David, we're not going to talk about container queries, even though that's some crazy CSS shit. That's
what we need more so than nesting.
I think so. Container queries are really important. They're a way, right now we have media queries in CSS. Is the page this wide? Then do this. Is the page this wide or this tall or black and white? Then do this. What it doesn't say is this div 400 pixels wide? Then do this. Which matters more and more because I like talking about to a JavaScript group because we write React components and Angular components and shit that's just, you have no idea what the outside page is doing, but you know what you're doing as a component. It's classic, you know, like on an iPad, your component might be really wide, but on desktop, it's really small. That's weird to think about because normally you think, whoa, desktop, so it's bigger. No, not always. Desktop might be in a column. So your calendar layout might need to be a column, not a, you know, there's not a one-to-one connection between screen size and what a component is doing. So there's such a thing as container queries. Let's not get into them too much, but here's a working version of them. So this is a grid layout. It's just 2 columns and there's a card in between the 2 layouts. As I resize this, you can see, I think the one of them is going to give up. See that? It's like, oh, I'm too narrow. I'm going to give up and change. That's not a screen size. That's not a media query. It's a container query doing that. And the other one on the left, which is in a wider column, is going to do it later. That stuff blows my mind. But what's going to blow your mind even more is see the padding on the outside of it is getting smaller as well. That's not a viewport query. It's a container unit, which is like, right? There's never been a thing that says, give me the unit of the size of the container it is. There's percentages. So if you had width, if you had a div and it said width 80%, fine. And then you put a div inside of it that's 80%, it'll be 80% of the size of its parent. So there is like nesting, but that's width. There's never, give me the font size that's 80% of the width of the parent. You can't like cross properties like that. That's some Ghostbusters shit that's not happening. Right? And now there is. So I'm in this Chrome Canary that has this. See this font size card component? Look at it as I get bigger.
What?
That does not exist. That's not a thing that you can do in CSS today, unless JavaScript gets involved and you start measuring crap. That font size is set here. No, look at these units. They're crazy. What? Okay. Yeah, and this is a CSS function. Max exists now. There's clamp and min. You've probably seen that stuff. But these container units are really strange. There's QI, there's QX, there's ones that are the minimum of both. There's about 5 or 6 of them that are based on the size of the comparison. Huh? Yeah. I don't know. So the way that I styled these things with the space around the edges, can you see my mouse go around? Yeah, right? So I designed that card. See, it has a container query, so that's that line that says it has to have containment. Then later on, there's an at container query. So I said I wasn't going to talk about container queries, but you can't avoid it really. And then it's using custom properties for the gap, which controls it. That gap is the query unit.
What's QI?
I don't know, I forget. There's a spec for it somewhere. Oh yeah, I just had it up. There you go. Right, so one of them's in the inline direction, one of them's in this direction. That's called logical properties in CSS, where you don't say top and bottom anymore. It's like uncool. It's like not politically correct in CSS anymore. You say block and inline. Because writing directions can change, and then it follows it in a nice way, which is cool, right? All right, so container units, super weird, super cool that exists. We're gonna keep going. CSS just gets weirder and weirder. Cascade layers. Check this out. This is crazy. Here's how let's do I'm gonna make a new pen, and we're gonna play a game, right? Here's an H1 tag. And it's going to have an ID of H1 also. Which one of these selectors will win? No, this one, because it's 1,000 million times more specific than this one is. The way CSS specificity works is like tags and then classes and then IDs and then inline styles, you know? This has one ID, which is like infinitely more specific than one class is, right? So this always wins, always. Let's try it right now. Color red. That's going to win if I put some cool text in there. That'll definitely be red. And then this is definitely going to win, right? Green, because it has a more powerful selector on it. Cool. Now let's type at layer. I win, and we'll put a really weak selector in there again. It says color pink. Maybe this will work. It's not gonna, because the way that you get this to work is to open. This is gonna work in the future. So here's the code from Miriam Suzanne that says, this has a really high specificity, color red, but this one's going to win because of this at layer rule. At layer, that's not a CSS thing. That's what I'm pointing at, is like, this is brand new shit. The way that I can get this to work is to open canary at the command line. Did you even know? I mean, I guess you knew you can open things at the command line. You're not children, right? But this is how we'll have to do this. So applications. No, wrong applications. Google. If I drag it here, I'll get the path, and then I'll put a. Why is it selected weird? Nah. How does ZSH work? Just type in what? Oh, you're right. And then I paste a command line flag, but I have to quit it first. I've never had to do this in my life.